So in a speed time graph, you should be able to explain the motion of an object. Like if I say an object is at rest or stationary. So if object is at rest or object is stationary or object is not moving, how we can explain this, that this object is not moving or this object is stationary? So what is the speed of the object which is at rest? The object which is at rest, what is the speed? The speed of this object is 0. So when we sketch a graph, a speed time graph for an object which is at rest, and this is a speed time graph, so how we explain, it will be a horizontal line on the origin which shows that the speed of the object is 0, because on the origin that is 0, then 5, 10 numbers will be there, but because every second the speed of an object will remain 0, so it will be a horizontal line. So whenever there is a graph to show that object is stationary, object is at rest, then it should be a horizontal line on the origin. Is it clear, the first part? Next is if an object is moving with a constant speed. So moving with a constant speed means that the speed does not change. So how we can represent that the speed does not change? So value of the speed should be same throughout the motion. Example, at this point it is 5 meter per second. Here also 5 meter per second. 5 meter per second and 5 meter per second. Point A, B, C and D. This is when time is equals to 0 second, time is equals to 1 second, time is equals to 2 seconds, and time is equals to 3 seconds. Now this is called a uniform speed or a constant speed. Because the speed is not changing, that's why we use the term that speed is constant or speed is uniform. What about acceleration? If you want to calculate acceleration, acceleration means change in the velocity from A to B. What is the acceleration from A to B? So what is the change in velocity from A to B? It will be 5 minus 5 divided by 1. So 5 minus 5 is 0. So 0 divided by 1, acceleration will be 0 meter per second square. If I calculate the acceleration from point B to point C, so what is the acceleration from C to B? 5 minus 5 divided by time interval is 1, so it will be 0 meter per second square. And from C to D, when I calculate acceleration, it will be 5 minus 5 divided by 1. So acceleration or change in velocity is 0. So all the parts, the velocity does not change or there is no change in velocity. So this object is having 0 acceleration or it is moving with a constant or uniform speed. So how we sketch a graph, what will be the shape of the graph? On x-axis we have time, on y-axis we have speed, and the numbers are there, like example 5, 10, 15. So in the beginning, at the start, when time is 0, what is the speed? 5. So when time is 0, speed is 5. When time is 1 second, at 1 second, what is the speed of the object? That is also 5. Then at 2 second interval, it is having a speed of 5. At 3 second, it is also having a speed of 5. So when we join these points, it will be a horizontal line. So whenever the object is moving with a constant or a uniform speed, it will be a horizontal line. Is it clear? The second part. So first one we discussed when object is stationary, and the second one we discussed that object is moving with a constant speed or object is not accelerating. So this it will be a horizontal line for speed time graph. Then the third case, when object is moving with a constant acceleration, uniform acceleration. What is the meaning of uniform acceleration? The term uniform acceleration means that speed is changing with the same, there is a change in speed, but it is changing with the same rate. So we have different positions, point A, B, C, and D. At this point, say it started with rest, so when time is 0, the speed was 0 as well. Then after 1 second, the speed is 5 meter per second. Then when time is equals to 2 seconds, the speed was 10. And then when time is equals to 3 seconds, the speed was 15. If I want to calculate the acceleration, which is a change in the velocity, so if I want to calculate the acceleration from A to B, so to calculate acceleration from A to B, the change in the velocity, at B it is 5 and at A it is 0. So the change in the velocity is 5 minus 0, and the time interval, this is 0 second and here 1 second. So time interval is 1. So acceleration is 5 meter per second square from A to B. The change in velocity in a unit time is 5 meter per second square. To calculate acceleration from B to C, the change in the velocity, that is 10 minus 5, because here it is 10, B it is 5, and the time interval, the time difference, that is 1. So it will come out as 5 meter per second square. And if we calculate acceleration from C to D, the change in velocity 15 minus 10, and the time interval, that's 3 minus 2 or 1. So it will also come out as 5 meter per second square. So the speed of the object is increasing, but its acceleration is same, or we can also say constant. So whenever object is moving with a constant acceleration, the speed will change with the same rate. Is it clear? So this is for an object moving with a constant acceleration or not changing acceleration. Now when we sketch a graph to explain this motion, what will be the shape of the graph? So on y-axis we have speed, on x-axis we have time. So when time is 0, speed was 0. When time is 1, the speed was 5. When time is 2, the speed was 10. When time is 3, the speed is 15. So when you join these points, how it will appear? It will appear as a straight line with a constant slope. So for a speed time graph, whenever a question is there, or in a question they give you the graph and they say explain the motion. So if it is a horizontal, if it is a line with a constant slope, it means it is having a constant acceleration. Is it clear? The concept of constant acceleration means the constant change in the speed. Any doubt till now? So constant acceleration, you will always draw a line with a constant slope. So this is representing that constant acceleration. If a non-uniform acceleration means acceleration is changing. So then there are two possibilities. Acceleration might increase or acceleration might decrease. So for a speed time graph, if the graph appear that the slope is increasing, it means for this graph acceleration is increasing. And here this shows that acceleration is decreasing. So acceleration can be constant. If it is constant, then it will be a straight line with a constant slope. If acceleration is increasing, the slope will increase, and if acceleration is decreasing, the slope will decrease. And the last part is about deceleration. If object is having a constant deceleration, what is the meaning of constant deceleration? The term deceleration means the speed is decreasing. So an object is moving and its speed is decreasing, but it is decreasing with the same rate. So it was example 30, then 20, then 10, and then 0. Here the time was 0, then time is equals to 1, time is equals to 2, and time is equals to 3. So when we calculate the deceleration here, it will be final minus initial divided by time. So deceleration will come out as minus 10. When we calculate deceleration from B to C, it will come out 10 minus 20 divided by time interval is 1. So it will come out as minus 10 meter per second square. And same is there for the last part, the deceleration, the change in velocity, that is 0 minus 10 divided by time interval is 1. So it is minus 10 meter per second square. So deceleration is same and speed is decreasing, but the deceleration, the change in speed is same. So what will be the shape of the graph? Example, if we mark the numbers here 1, 2, 3, this is 0, and this is say 10, 20, and 30. So when time is 0, it was 30. When time is 1, it is 20. When time is 2, it is 10. And when time is 3, it is 0. So when you join the points, it will appear as a line shown. Is it clear? This part, the speed time graph. And the last part is non-uniform deceleration, means deceleration is not same or not constant. Like maybe in the beginning it is changing faster, but then the change is decreasing. Speed is decreasing as well as the change is also decreasing. Example, it was 30 at A, at B it is 20, at C it is 15, and at D it is 13. This is when time is equals to 0, time is equals to 1, time is equals to 2, and time is equals to 3. When we calculate the deceleration, the change in velocity 20 minus 30 divided by 1. So deceleration is minus 10 meter per second square. When we calculate deceleration from B to C, it is 15 minus 20 divided by 1. So deceleration is minus 5 meter per second square. And when we calculate from C to D, it is 13 minus 15 divided by 1. So deceleration is minus 2 meter per second square. So in the second example, the deceleration is not same, or deceleration is also changing. So we call that as a non-uniform deceleration. So it will be a graph like this. Is it clear to everyone? The motion. Now I'll give one example so that you have a better understanding to explain the motion of an object by using a speed time graph. So first, a quick revision so that you can recall what we have discussed for a speed time graph. Speed time graph is there and it is a horizontal line on the x-axis. What do you explain about this? The motion of an object. It's a speed time graph and the line is, or horizontal line is there on x-axis. What you can say? So you can say this object is at rest or stationary object, or object is not moving. Because the speed is 0, it shows that this object is not moving. Another graph, a speed time graph, again a horizontal line, but this time it is not on the x-axis, it is above the axis. What you can say about the object? So this object is moving with a constant speed, or speed of this object is not changing. If it is a straight line for a speed time graph, what you can say about the object? Speed time graph, a straight line with a constant slope. A speed time graph, a straight line with a constant slope. No, you cannot say it is accelerating. You have to use a specific term. So when speed time graph, it is a straight line with a constant slope. What you can say? You can say it is constant acceleration. You cannot simply say accelerating, because You have to be specific when you write in exam that this is having a constant acceleration. Constant acceleration means acceleration is increasing. If it's a speed time graph and the slope is increasing, what you can say about acceleration? So whenever the slope is increasing for a speed time graph, you can say acceleration is increasing. And if it is a speed time graph, so when speed time graph is there, we use the term acceleration. When distance time graph is there, we use the term speed to explain the motions. So for this part, what we can say acceleration is decreasing. As a slope decreases, acceleration decreases. And the last part, if it is a line, the speed is also decreasing. So we can say constant deceleration. And if the line is not a straight line, the slope is continuously changing, so we can say non-uniform deceleration. So non-uniform deceleration or not a constant deceleration. These are the graphs which you have to keep in mind. When object is at rest, it will be a horizontal line on the origin. Object is moving with a constant speed, it will be a horizontal line above the origin. When object is moving with a constant acceleration, constant or uniform, it will be a straight line with a constant slope. If object acceleration is increasing, it means the slope will increase. Acceleration decrease, slope will decrease. If the value of the speed is decreasing, you call that as a deceleration. If it's a straight line, then constant deceleration. If it is a curve, then it is a non-uniform deceleration. And keep one thing in mind: when distance time graph is given, use the term speed to explain the motion. And when you have speed time graph, use the term acceleration to explain the motion. So when speed time graph is there, we use normally the term acceleration. When distance time graph is there, we use the term speed to explain the motion. So this is a quick revision what we have discussed yesterday for a distance time graph. For example, this is a distance time graph, not a speed time graph, and it was a horizontal line for a distance time graph. What you can say about the motion of object? A distance time graph in which the distance is not changing. What you can say about the motion of an object? So as the distance is not changing, you can say this object is at rest. That's right. I want participation from everyone, not like one or two students. If you have a distance time graph, this is what we have discussed yesterday. If you have distance time graph and it is a straight line, what you can say about the motion of an object? So what we can say about the motion of this object, we can say this object is moving with a constant speed. And I told you, whenever distance time graph is there, use the term speed to explain the motion. Distance time graph, what you can say about the motion of an object. So here you can say speed is increasing, object is accelerating, or you can simply say speed is increasing. And whenever speed is increasing, we use the term accelerating. And if we have a distance time graph, for an object, what you can say about the speed here? Or what, yeah, decelerating, or what about speed? You can use the term speed is decreasing, or we can say this object is decelerating. This is what we have discussed yesterday. And today we discuss speed time graphs. So when you have a speed time graph, when it is a horizontal line on the origin, what you can say about the object? Horizontal line which is on the origin. So object is at rest or stationary. If it is a horizontal line above the origin, for a speed time graph, so you can say it is a constant speed or no acceleration or zero acceleration. Like there is no change in speed, that's why we say zero acceleration. If the slope is constant for a speed time graph, what you can say about the motion? You can say it is constant acceleration. For a speed time graph, the slope is increasing, and other one the slope is, because of space I'm drawing both of them in the same. So what about A? What is happening in A? What happened to acceleration? So for A, acceleration is increasing, and for B, acceleration is decreasing. You may have a graph in which the value of the speed is also decreasing, and then again it has two possibilities. That it might have a uniform deceleration or constant deceleration, or it might have a non-uniform deceleration. So speed and time, if it is a straight line, then it will be a uniform, and if it's a curve, then it will be a non-uniform. So here it is a uniform or constant deceleration, and this part, it is non-uniform deceleration. Is it clear? These graphs about the distance time graph and velocity speed time graph to explain the motion. Then calculations, what we can do, from distance time graph, what we can do, we can calculate speed, and from speed time graph we can calculate two things. Number one, we can calculate acceleration or deceleration, or we can calculate the distance traveled by the object. But that calculation we will do next session, next part. Today we'll do only about the distance and speed time graph and explain the motion. So some questions related to the topic now. The calculation part we'll discuss next week in the session. Okay, this is a speed time graph. You can use the screen annotation to state the answer. The graph shows how the speed of an object vary with time. So this is how the speed of an object is changing with time. Which row describe the motion at times p and q? At times p, what is happening to the motion of, what is the motion of object at time p and at time q, this region? And it's a speed time graph. I want participation from everyone. Yes, Heather, Abdullah Khan, Saim. It's a horizontal line above the origin. It's not on the origin, it is a horizontal line above the origin. So when it is a horizontal line above the origin, as you can see here, a horizontal line above the origin. So when it's a horizontal line above the origin, what we can say, it is constant speed. So at this point, at P, it is moving with a constant speed or zero acceleration. And at Q, it is accelerating or acceleration is there, or it is having a constant acceleration. So which option is the right one? A constant speed. P, it is moving with a constant speed, and Q, it is accelerating. So C will be the right answer. Is it clear? Why correct answer is C? An object is traveling in a straight line. The diagram represents a speed time graph. Which label object is accelerating at a changing rate? Means acceleration is changing. At A, acceleration is constant. At C, acceleration is 0 because it is a horizontal line. At D, deceleration is constant. But the question is, which part acceleration is increasing or changing the rate? So at point B, the acceleration is increasing. That is why B is the right answer for this. Is it clear to everyone? Any doubt related to the class today? We will discuss more questions from these graphs, and next session we'll do calculation as well from distance time and speed time graphs. Any question related to the class today? So I'll end the session and share this with you.